Okay, so since we have covered trigonometric ratios of any angle, now we can talk about the law of sines. Okay, law of sines, very simple. So we but to understand how law of sines work, we have to first cover the standard notation for triangles. Okay, the standard notation for triangles is that if you draw a random triangle, so law of cosines apply for any triangle, not only in right angles, but for any triangle. Let's say just a random triangle like this. Okay, for any triangle, you start with labeling the vertices. Okay, you have 3 vertices, and in conventional, standard notation, we've labeled them A, B, C. So you can start with any vertex. Say start from here, A, B, C. Okay, and now the sides opposite to each angle will be assigned a lowercase letter corresponding to that letter. Okay, so for example, you have angle A here, and the opposite side is the side BC, right? So side BC, we will assign lowercase letter a to it. Okay, the side will be assigned a lowercase letter corresponding to its opposite angle. Okay, just now， 每一个边呢，我们用小写字母，那么用哪一个小写字母呢？我们用这个边的对角的那个字母来表示。所以角 A 对边 A， make sense? Yeah. And then of course, for angle B, the opposite side will be side B. So side AC is opposite to angle B, right? So we use lowercase b, and similarly for side AB, we use side C. Okay, you can start with any order. So say that I'm going to draw another one. This is right angle. Maybe like this. Now you can start, say, with here, A, B, C. Doesn't really matter. Okay, and again, angle A, you go to the opposite side. This is side A. For angle B, this is side B. For angle C, this is side C. Okay, so you can start with any angle, and then you always find your opposite sides and label the sides. Okay, make sense? Now, understanding this, the law of sines states the following. So side A over the sine of A equals side B over the sine of angle B, and then equals side C over the sine of angle C. The law of sines. It's very straightforward, very simple. Okay, make sense? Basically, the ratio between every side and the sine of its opposite angles is the same. We won't prove this because to prove it is a math competition, and it requires advanced knowledge of geometry. So we won't be able to prove it, and you don't need to know how to prove it. Okay, in your school, you just need to remember this thing, and then, yeah, and do the questions. Okay. So, yeah, any question about this? So to remember this, it's very easy, but always remember you're gonna do the opposite sides and angles and stuff. Okay. For example, let's say we have a triangle here. Just say this is 100 degrees. Maybe this one is 30 degrees. Say that we have a side. Maybe maybe this side is 4. Okay, and then you're gonna find out the side lengths of the other 2 sides and everything. Okay. Yeah, so we first find the angle, right? So this is 100 degrees, this is 30 degrees, and this one is 50 degrees. So you find out all the angles, and you set up your law of sines, right? So you say 4 over sine 30 degrees equals to, you can label them. Let's say A, B, C. So this is side C, this is side B. Okay, so we say side B over sine B. Sine B is 100 degrees. For C, side C over sine C, so sine 50 degrees. And 50 degrees is the unknown angle, but we can use the sum of internal angles to find it out. Okay, does that make sense to everyone? You set up this and then just evaluate, right? So wouldn't it be hard? Sine 30 degrees is what value? Anyone? What is sine 30 degrees? It's a special angle. Does anyone remember using unit circle? Chris?
Can I use a calculator for this? Like if I'm on test or something?
What's that? I didn't hear
Like
that.
if I'm on a test or something, can I use a calculator for this?
Yeah, of course, yes. But it's a special degree is special value, right? So let's see if anyone is
1/2. It's 1/2.
yeah, 1/2. Very good, right? You can use a calculator, but you don't have to, right? It's this special right triangle. Let's review it again. Special right triangle, like this, 30 degrees or pi over 6. It's 1/2. This is 1. This is √3/2. So sine 30 degrees sine pi over 6 is 1/2. So 4 divided by 1/2 is 4 times 2, so 8. Okay, and 8 equals to both of these. And you can just solve for B and C. So B will be 8 times sine 100 degrees. C is 8 times sine 50 degrees. And use a calculator for these. For that, they are not special values, right? So use a calculator, whatever. Yeah, that's basically it for law of sines. Okay, so Owen, are you able to grab your textbook now? Because I want you to go to the sine law and see if they have a section called the ambiguous case of the sine law. Do you have your textbook with you? Yeah, if you could go to 2.3 and see if they have what we call the ambiguous case of the sine law. See if they have that section. If you have that section, we can cover it. If you don't have, we can save for later because some textbooks cover it, some don't. I'm gonna grab a calculator too.
Yeah, there's a section called the ambiguous case.
It has the ambiguous case.
Yeah.
Good. Then let's talk about it. Okay, good. All right. So to use this sine law, we have some problems. So so this in this example is pretty easy. We just need to find the side lengths, right? But what about say let's say we have another example. Let's say we have but we have different values. Wipe this out. Let's say we have this. And then we have say this side C, let's say it is 8. We have another side here, maybe it is 12. And yeah, and the others are unknown. Okay. Now, in this case, we're gonna first find out the side and also gonna find out each angle. Okay. To find out the length of each side and the degree measure of each angle, we usually just say solve the triangle. Solve the triangle. Solving the triangle is the most common type of question that you will see in the sections of law of sines and law of cosines. Okay, law of sines, law of cosines. Usually the questions are just the most common question and the most basic type of question is to solve the triangle. Solve the triangle means that you're gonna solve for each unknown length and each unknown angles. Okay, so solve all unknown angles and sides. Okay, and this is actually in preparation for your physics 11, physics 12. Yeah, physics 12. you will be asked to solve these because you have to do force and stuff. Okay, you're gonna have a lot of triangles and you have to do this. Okay, so yeah, so since Owen has that ambiguous case section, maybe today we're just gonna cover log signs, okay, Owen? Because you are still, you saw, yeah, it's not at we don't have to rush, right? So maybe next class we'll talk about law of cosines. Okay, we'll talk about law of sines and we'll do some radicals. So yeah, so if we have this case again, we set up our equation, right? So let's write our equation. So first we have 8. Can anyone use the law of sines and set up the equation here? Or maybe Owen, you should do it because this is, you're gonna do this first, right?
Okay, so you have C
C is
C, which is 8 over sine 50 degrees
good.
equals to 12 over sine B
Very nice.
equals just A over sine A.
Yes, very nice. Very good. Okay, it's pretty easy, right? Everyone makes sense? Just sine over the sine of opposite angles. Okay, shouldn't be hard to remember. What am I doing here? I'm gonna copy it down here and see how we can solve it. Okay, so Owen, what do you think we can solve first? We have 3 unknown numbers, right? Can we solve B first, or can we solve A, small a or big A first? Just an idea. Any idea?
Maybe you can solve sine like B first.
Very nice. Very
We
nice.
have the 12.
Yes, very good. So everyone, in this kind of situation, we can only solve for sine B first. Because if you want to solve for A and sine A, well, let's remove this first. You will see that you have 2 unknown numbers, right? A is unknown, sine A is unknown, then we are not able to solve it. To solve anything, we have to, well, get only 1 unknown variable, right? You have 2 unknown variables in an equation, then it's not possible. Make sense, everyone, right? So we first solve for sine B, and then we use inverse sine to find out B, right? Okay, so we're gonna first solve this part. Very good, Owen. And then if we solve this part, how do we solve it?
You get the 8 over sine 50 first. Over sine 50 degrees.
Sine B
Like-
equals,
It's like 10.4 or something.
you already, give me an equation first. Sine B equals,
okay. Sine B equals so sine 50 degrees. 12. Hold on, sine B, move it to that side. Okay, so that'll be sine 12 times sine 50 over 8.
12 times sine 50 over 8. Yes, very nice. Okay, so fractions equals fractions, we do cross multiplication, right? So 8 times sine B is 12 times sine 50 degrees, and then we just say 12 sine times 12 sine 50 degrees divided by 8. Okay, Justin, that makes sense? Cross multiplication, okay? Yeah. Yeah, just try out this value. This 12 is not possible, actually. Okay, so I'm gonna change it to 9. The 12 is impractical. Okay, this is practical. Okay, so now we have so we have 9 times sine 50 degrees divided by 8. Okay, correct? 19, 9. Okay, and what is the answer? Use a calculator. This is roughly 0.86. Okay, but so how do we find angle B?
Sine inverse. Can you sine
Yep.
inverse that?
Inverse sine, good. And Clavon, yeah, I got your message. Okay, I'm gonna just do Justin's. Yeah, I do believe Justin's schedule is more accurate, is more detailed. So the inverse now, to do inverse, everyone, try not to use this estimated value because this is at roughly, right? We can, because you have a scientific calculator, you can just put this inside an inverse sign, right, Owen? So for because if you use a rough estimate, maybe the answer will be off by a little bit. Okay, we want to make our answer as accurate as possible, and this is also a requirement in your physics 12. So try to practice this. So B is the inverse. Well, we can just put this value in. Again, this is estimate value, so we can just put this in. So that's why I wanted an equation from you, Owen. Okay. So actually, I'm gonna wipe this out. Don't do this. Or maybe don't do this. Plug this, okay, into your inverse sign directly, and your calculator allows you to do so. Okay. And what do we get here? Let me put in and see. We've got 59.5. 59.5 degrees. Well, it's 59.51929, whatever. Okay, but to get an integer or to get one decimal place, two decimal places really depends on the question. Okay, the question usually will tell you, or in an exam, in a quiz, your teacher will tell you to what decimal place you should keep. Okay, so just ask your teacher for this. Now, let's say we keep one decimal place, then we get this. Okay, and here comes a problem. The problem is that we know that not only this value gives you the sign, gives you a sign value of well, of this, right? We have another angle. Remember from last time? You have two angles. So let's use a unit circle. So in a unit circle, we know that for any sign value, let's say 0.86 or anything like 0.4, you can have an angle in the first quadrant, or you can have an angle in the second quadrant, right? They both have the same sign value. And this is one of the ambiguous cases in, well, the ambiguous case in your law of science is not exactly this, but it could be ambiguous here, right? For example, here, you can add 90 to it, and that would be 149 degrees, right? Which is also a possible answer. Okay, does that make sense, everyone? So the problem is that how do you know about this angle? This angle could be, let's say maybe in another calculation, say that you calculate it to be 60 degrees. It could be 60 degrees, it could be 150 degrees, right? It's both 60 and 150 gives you the same sign value. Okay, so how do we determine which one is true? Now, a general way to do this is that there's another fact for triangles is that if you have a longer side, then the angle opposite to it will be bigger. So say that you have, I'm gonna work this out. For any triangle, we have the following fact. So if you have side A greater than side B and greater than side C, then angle A must be greater than angle B, and which is greater than angle C. Okay, now combined with this fact, we are able to determine which one is true. Okay, so for this question, the answer is 59.5. Does that make sense? If you go back to your question, if this is 59.5, I think it makes perfect sense, right? The side 8 is opposite to the angle 50 degrees. The side 9, which is only slightly bigger than this value, has this angle about 60 degrees. It makes perfect sense, right? If you add 90 to it, that will be 149.5 degrees. This, first of all, the sum of it and 50 degrees exceeds the sum of interior sum of angles, sum of interior angles, right? If you add them up, that's 200 degrees. It's already bigger than 180 degrees. It's impossible. Okay. And second of all, it doesn't really make sense, right? 8 and 9, they're pretty close in terms of side length. And then how can we have the two angles that are so different to each other, from each other? Doesn't make sense, right? Okay, makes sense. So that means we just need to keep the first value. Keep this. Okay, so Justin， 我看听没听明白啊？这里首先对于 triangle 来说，有个很重要的一点是，中文说的很简单，就是大边对大角，好吧？边长的那个边对着角的就会大一点啊，小边短边又对小角。OK， 大边对大角，小边对小角啊，记住这个。这个的推理我们就不推了，这个也是竞赛的推了。那么在这道题里面，我们刚刚是不是做出来这个角壁是50.5度啊？直接解方程，对不对？解完了之后，问题是在于不光是比如说60度吧，简称是60度，60度呢能给到我们这个值，但问题就是在于你加上90变成150度，变成149.5度，它也是这个 sin 值，对吧？所以我们有个问题就是，我们这个角到底是59.5还是149.5度呢？对不对？那我们就想通过2个方法来确认。第一个就是三角形的咬合是180，对吧？你要是取149.5加50都已经200了嘛，对不对？那明显不可能嘛，就不行。这是一种判别方法。OK，the sum of interior angles is one of the methods that we can determine which one is true. OK，and another one is this， 对吧？大边对大角，你一个边是8，一个边是9。9的这个边只比8的这边略长了一点，那你对着角不可能说是从50直接变成150了，这不 make sense 对吧？那角3倍大，你边长肯定也大很多嘛。所以从这2点就看出来，不可能是第2个答案。所以呢，我们就只能保留第1个答案，50.5度。Okay, does anyone else have any question about this part? Okay, now you might have another case. Let's say we have another case here. Let's say that we have this. Let me draw one. Okay, let's say we have, say this is 30 degrees, and then we have maybe this side is 7, this side is 15, and there's an angle here, right? Okay, so if you use inverse sine to find out that angle, and let me see if the values are possible. So 7 over 30. 7 times 15 30 degrees over 7. That was too much. Maybe okay. Okay, let's just say hypothetically. Okay, so I have to find out value here is not that easy to find. Let's say hypothetically. Okay, say that this is a big number. Okay, now let's say we have like maybe 14 here. Now the problem is that if you do a log sines, this value, because inverse sine only gives you a value that's less than 90 degrees, right? Less than 90 degrees. What if say the inverse sine gives you 60 degrees here? Now we know that bigger side corresponds to a bigger angle. So you can basically make a presumption. So this side is a lot bigger than the other side. So probably the angle here should be bigger. Okay, so maybe it's you add 90 to it, maybe it's 150. But 150 here is like 180, right? So maybe let's say if the calculator gives you 40 degrees, then maybe you should add 90 to it and it becomes 130 degrees. Okay, it's based on an intuition. If the side is much bigger than the other side, maybe it corresponds to a bigger angle. Okay, but this is only an intuition. If you don't confirm that your intuition is correct, you can always find the first. So say that you can suppose it to be 40 angles or 40 degrees, and then you can find out the degree measure of the other angle, and then find out the other side, and see if everything makes sense. Okay, always remember the bigger side corresponds to bigger angles. If you use the wrong one, then say that the wrong one is 40 here, then you will see that if you use 40 here, 30, 40 to 70 degrees, right? 70 degrees, maybe this one is 110, and say that you find out you will see that it doesn't maybe really make sense if you find out the size. Maybe the size here is 9, let's say, okay? Then you should see that bigger size should be corresponded to, should have bigger opposite angles, right? And this triangle violates the basic principle. Okay, so for ambiguous cases, if you're not sure which one is the correct answer, you can try both. You first try one and see if the end result gives you a triangle that has, well, bigger size opposite to bigger angles. If you have that, then that's correct. If you use the wrong angle, you will see that it's incorrect. Okay, you will have bigger size opposite to smaller angles. Okay, basically that's how you figure out the ambiguous case. Okay, anyway, let's finish this one, this part. So after you've got 59.5 here, what's next? Owen, what do you think? We have 8 and then 9, and then we have 50, and then we have 59.5. How do we solve for A and sine A?
Okay.
You know 2 angles now.
But isn't angle B like an assumed value?
Yeah, it is
Because
0.5 because for the other possible value, it exceeds 180. Remember, the other one you have to, the other one is like 180 minus it, right?
yeah,
Which is 120.5. Okay, it's not. I mean, yeah, you can choose 59.5 first and try it, right? But as we just discussed, 8 and 9, they're pretty close, so probably the angles are pretty close to each other. Okay, 180 minus it is 120. It's not, yeah, the sum is not more than 180, but yeah, we try this first, okay? So if B has this degree measure, then what about A and sine A? So now you know B and C.
and can you just do 180 minus angle B plus C?
Yes.
Make it angle A.
Yes, exactly. Okay. So we first use the sum of interior angles to find out angle A. So this one is 180 degrees minus 50 degrees minus 59.5 degrees. And it will give us 70.5 degrees. Okay. So for ambiguous cases, you can always try it. Okay, I believe the easiest way is just to try it. So first you try 59.5 degrees, and this gives you angle A to be 70.5 degrees. Okay, and then what's next?
And then yeah, now you have it. So then you solve. So it's sine 7.5.
Good. Okay. So after we figure out angle A, everyone, we use this equation again, law of sines, right? And try to solve for the side A.
So it's A equals 8 times sine 70.5 over sine 50.
Yes. And that will give us, so this again, cross multiplication, guys. Okay, so 8 times sine 70.5 degrees. Cross multiplication gives you, well, first gives you A times sine 50 degrees, right? Equals this. cross multiplication. And then that means A equals to 8 times sine 70.5 degrees divided by sine 50 degrees. Okay, just say that makes sense to you? This whole cross multiplication thing. And using a calculator, this gives you 9.8, roughly. Okay, again, we keep one decimal place. It's 9.844 something, okay? Let's say it's just 9.84 or 9.8. And then we'll go back here, 9.844, right? Now, what happens? Does it make sense? Is it bigger side opposite to bigger angles? It is, right? You see, 8 is the smallest side here, and its opposite angle is the smallest. 9 is the second largest side here, and its opposite angle is the second largest, right? And the largest side here is A, which has the largest opposite angle. So we have this, larger sides are opposite to larger angles. Okay, Owen, that makes sense to you? Okay, does that make sense to everyone? Okay, yeah. So that means we have the correct case here. Okay, let's try what if we use the other case? What if we use the other possible value for B and see what happens, okay? So angle B equals this. Now, the other possible value is that we always subtract it from 180 degrees, right? Because if you look at the unit circle, if this is theta, then the other angle that gives you the same value as a sine theta, that will be, well, this angle, right? And this angle, we know that this angle is theta, so the other angle is pi minus theta. So 180 minus it. Okay, so the other possible value here for angle B is 180 minus 59.5 degrees. What do we have this case? Let's give it a try. So this is 120.5 degrees. I'm gonna grab this triangle here. Maybe make it smaller. Let's have a look, okay? So now, angle B is, okay. Angle B now is 120.5 degrees. So again, if you look at side lengths, it doesn't really make sense, right? But if you use this case, you will see that eventually we don't have the correct triangle. Okay, so if we have this, what is angle A? So when we subtract B and C from 180 degrees, right? We use the sum of interior angles. So 180 minus 50 minus 120.5 degrees, and that will give us 9.5 degrees, right? 9.5 degrees. And then let's give it a try. So we have the same equation, 8 over sine 50 degrees. And that equals to, in this case, we have A over sine 9.5 degrees. Okay, and let's see if we have a possible triangle here. So we have 8. So A is 8 times sine 9.5 degrees over sine 50 degrees. Sine 9.5, sine 50. We get 1.72 something. And then we put it here, 1.72. Let's see if that makes sense. Now 8. So 8 is the middle, is the second largest angle. So second largest side, you have a second largest angle. 9 is the largest side, it has the largest angle. 1.72, this A, it has a least side, right? And it has its opposite angle is the least. So it also makes sense, right? And also it satisfies the basic requirement of a triangle that the sum of two sides is greater than the third side. Right? For a triangle, the sum of two sides must be greater than the third side. Okay? And so it seems like this is also a possible triangle. So that means now we actually have two possible triangles in this case. Okay, and this is the ambiguous case. So you try both of them and see which one works. If both work, then you actually have two possible answers or two possible triangles here. And it is possible. Okay, it is possible that you have two possible triangles. To judge if the resultant triangle is possible, you're going to use this and also the basic triangular inequality. Okay, so the sum of two sides is greater than the third side. I believe everyone knows this, right? Because if two sides, if you sum up, if it equals to a third side, you don't have a triangle at all, right? A side is this long, this is side C, this is A, this is B. So if A plus B equals C, you just have, well, just a single line segment. You don't even have a triangle, right? The sum of any two sides has to be greater than the third side. It's also called triangular inequality. So make sure your triangle satisfies all the requirements for a triangle, and then you will see if your triangle is legit or not. OK， Justin 看有没有问题啊？我们呢这个地方，因为每一次它这个 inverse sin 给出来这个值啊，它可以有两个不同的值，一个是本身 inverse sin 值，还可以用180去减。有两个值，这两个值给到你 sin 是一样的嘛，对不对？那具体哪一个是对的呢？我们可以两个都试一下，两个都试一下，把你的最后 triangle 找出来。找出来之后呢，看看你的 triangle 是不是一个 possible triangle。怎么看呢？就看这两个。第一个叫做大边对大角，确认一下看行不行。第二个呢，就是看看是不是两边之和大于第三边。三角形有要求嘛？两边之和大于第三边，对吧？因为如果你两边之和跟第三边一样大，那就没有 triangle 了，这就是条直线了，对吧？两边之和一定要比第三边大，你才能说白了就是说这样能拱起来嘛，对不对？或者说你看两点之间直线最短，对吧？两点之间 C 是最短的，你 A 和 B 上去又下来肯定比 C 要长，没问题吧 ？OK， 所以 A plus B is greater than C. The sum of any two sides of a triangle must be greater than the third side. Okay, so if your resultant triangle satisfies both criteria here, then the triangle is legit, is possible. In this question, you have two possible answers, and this is the ambiguous case of the law of sines. So sometimes one of the cases is impossible. And every time there must be one case, one possible case. Okay, so one possible case or two possible cases. Okay, Owen, that makes sense? The use the law of cosine, just give it a try. Yeah. Any question, anyone? Okay, if not, let's do another example and then we'll move on to radical functions, okay? Next time we can do some more questions. I had some practice tests in my old iPad. Okay, anyway, we switched on iPad. I'm gonna just search some science questions here. Let's say ambiguous case. Let's find one more question. You see, these are possible questions. To a question here. Log signs, ambiguous case. Choose one question and maybe let's just do question A. Okay. So the question is asking you to state the number of possible triangles that can be formed using the given measurements. So as we explained, you either have one possible triangle or two possible triangles. Okay, so you have to try. Okay, does anyone, okay, it's a pretty lengthy process, right? So to keep you guys focused and to understand if you guys have understood what we talked about, let's, I'm gonna assign each stage to different, to each one of you, okay? So Justin, could you first give me an equation using law of sines? This means angle A is, M means measure, okay? The measure of angle A is 110 degrees, okay? And then sine C inside A is 32.
So you want wait. I mean the things you did fractions.
Yeah, this is called law of sines, okay? Law of sines.
Of
Yeah.
science.
Mhm.
First you have the
A
this-
over, okay.
so wait.
This is a law of sines.
Right.
Easy to remember, right? A over sine A, B over sine B and stuff, right?
ABC.
Mm-hmm. So that's
So we have the C and the A, so the M like mention wait what's the, I forgot what's the name of it, like, so anyway the first one is B, the B is 100, wait no,
okay. You just need to plug in.
oh
Plug
I see, so it's 32 over like 110 degrees.
10, yeah. 32 over what?
Over like 110 degrees.
Like this?
And yeah,
No, there's a sign here, okay? A over sine A. A over
Over.
sine A.
so
Where's
we
the-
need this. It should be like 110 degrees.
Yeah, 32 over sine 1. Does that make sense, right? Just plug in, but remember the
Yes.
sign, because it's law of sines. Law of sines. Law of sines. You must have sign in it.
Science, okay.
Okay?
And equals to B over sine B.
Yes. Both are unknown. And then
And then equals to 19 over sine C.
good. Then that's the equation. Yes. Okay. Which do you think we should solve first? There were 3 unknown variables, right? Which 3?
Right.
Which 3?
They're the B, sine B, and C.
Which one should we solve first?
Sine C.
Very good, because that's the
Have the
one
C.
with only one variable. Good. So what is sine C? Sine C equal
Sine C equals to, wait, wait, let me think about the next step.
I'm gonna make it for you like this, okay? Cross multiplication and
Oh yeah, multiplication. So the the sine 110 degrees times 19.
Mhm.
Like that's that's a denominator,
That's the
And-
denominator.
and
Mhm.
over the sine like 32 times sine C, I think.
Yeah, okay, so you cross multiply, you get
Yes.
32 times sine C equals to 19 times sine 110, right?
Yes.
And then what is the angle C? What is sine C?
We should use calculator here, right?
No, I need an equation first.
Okay, so 19, which is equals to 19 sine like when same things divided by 32.
Yes, this divided by 32, right?
Yes.
So divided by 32, and now we can find a value. But as we said, if you find a value here, it has to be an estimation, right? Because it's a decimal. So to
Yes.
find out angle C, what do we do?
To find that angle, we use sine inverse.
Yes, we use inverse. Good. We put inverse sine, and what is the value putting here?
So inverse sine, and we have the same things like we got for up. Yeah, these things.
Very nice. We're putting
Just
high.
down.
Yeah, very nice. Okay.
Oh, and we got a number.
Yeah.
It's a
Yeah. So I'm gonna calculate the value now in a calculator, and that's 33.9. So let's just get integers 34 degrees. Okay.
okay.
Good.
So that's E.
Okay. So does 34 degrees work? We don't know. So now we have to do the ambiguous case, right? Okay. So a possible answer here is 34 degrees. And what is the other possible case?
Use 180 minus the I forgot what the minus was. The
Minus
30.
minus 34.
Yes,
okay.
minus.
Yeah, make sure you understand why. Because 34 degrees, let's draw it here. This is 44 degrees, and it gives you a sign. Remember, the sign is y.
Right.
So yeah, the length here, this is sine y. This is y. This is sine 34 degrees, right?
right.
To yield the same value, you can have another angle here, right? Say this is also 34 degrees, and this sine gives you just exactly the same value. Make sense?
Makes
那
sense.
对吧？就 sin 看 y 嘛，对不对？所以是不是有两个只要你这个同样都是 sin 它14度这个值啊？那你说
知道。
对吧？那另外这个角度它的角有多大呢？那角度都是从 x 的正半轴开始转的嘛，对不对？另外这个是这么
是一样的，
是不是180减34啊？
但是大180，对。
对，所以我每次先把 c 找出来，用这个 inverse sine 找完之后呢，两个 case 就分别为它本身和180减它。
OK，
明白了吧 ？OK。Yeah. So Torres Clown, does that make sense to you guys? Yeah. Okay. Good. So now we have two different cases, and then here we have 150, so 146 degrees. Okay. So I'm not sure about the first case, but is the second case possible? Anyone? Always say it's impossible. Why?
Because that added together is already like well over 180.
Yes.
Added together with the angle A.
Yeah. So Torres Clown, that makes sense. If you choose a second case, yeah, the sum of interior angles is well over 180. Okay, so Justin, does that make sense? 你看第二个 case 一定不可能啊，因为146，你这不是有个110吗？那加一块已经超过180了，这不可能。再要内角和是180嘛，对不对？ So second case is impossible. That means the first case must be possible, because it's either one or two. Okay, so that means at this step you don't actually have to try the first case, because the question didn't ask you to solve the triangle, right? The question is only asking you to state a number of possible triangles. Then the answer for first one is just one possible triangle. Okay, one triangle. That's the answer. If the question also asks you to solve the triangle, then just proceed with 34 degrees, right? Get angle B and then get side B. Okay, you just solve the triangle. That's it. Okay, make sense? Yeah. Okay. Then for any other question, basically the same. All right. If you do more questions, you will see that if the degrees are possible, then the triangles are actually possible. Okay, if you try more questions, you will find this. But yeah, just need to try, and because most of the time you're gonna solve each triangle. See, that's the most common type of question. So you have to try both cases, solve both triangles, and that's it. Okay, so Clavon Torres, any question? Do you guys think you want to do a practice? Okay, maybe wait until you reach trigonometry unit, and then we can do a practice. Okay, more practice. So you can do this for homework. All right. So let's use the rest of time. So Owen, that makes sense. Any more question for you? This is basic for you. Yeah. Okay. So that makes sense. Then we go to radical expressions. Okay. So for radicals, I have Clavon's homework. Basically, everything is correct. There's some minor issue. I'm gonna find them first. And for Justin, are you familiar with arithmetics of radicals? Like, do you know how to multiply them and stuff, and how to simplify them for radicals? 就是那个根号那些乘法除法的会做吗？
我们考试考完，我拿的满分。
哦，那就没问题，对吧？Okay. The Clavon, you said the method, yeah. Both of methods are correct. It's just there's only one problem with the estimation of the values. I meant, let's see, where can I find it? Yeah, I meant if you look at your page 7, question 6, you said that's the method your teacher told you to do. Okay, maybe I'm gonna show it here. So
Yeah. Like I asked him, and then he said like that's what you should do.
what? Okay, then well, the teacher is giving you the wrong method because for some values you can even check it. It's not even the correct value if you use a calculator. That's not how you get the value. So, well, most some teachers they're not actually very familiar with the subject matter. It happens, okay? It happens sometimes your teacher give you the wrong method. Okay. So I'm gonna give you the correct method, and I can prove to you this is correct, okay? Because using your teacher's method even gives you wrong answers. Okay. I'm gonna airdrop to my airdrop everyone. Okay. So airdrop here so that everyone knows what we're talking about. Okay. So let's first mention a very simple thing is that, so this is Clavon's homework. So come on, see here, even sometimes, most of the time you got your answer correct. I want you to cancel out terms first. Okay, cancel out your terms first, because that will make things easier. So let's say question F. When you do this, it takes a lot of time, right? Because you didn't cancel out terms first. You can cancel out terms first. If you cancel out, you see that 128 and 18, they are both even numbers, right? So just divide it by 2. When you divide it by 2, the numerator becomes 64, and the other one becomes 9, right? 18 divided by 2 is 9. 128 divided by 2 is 64. In this case, we will take a square root. The top becomes 8, bottom becomes 3, and that's it. So Clavon, that makes sense? Cancel out terms first, okay? So Owen Torres, that makes sense? Okay, just Justin, you got it you got a full mark, but make sure you know this, okay? Yeah, so for G, Clavon, if this one you actually got it wrong this step, but anyway, if you cancel all terms first, that'll be easier. So let's try it, okay, Clavon? So if you do this, 48 and 147, is there any common factor? So your
12?
first, what? 12?
Wait, no.
Okay, how do we determine the common factor here?
We can
Mhm.
use like the division thing, like
Yeah, so you first try. Okay, so everyone, when you're trying to find a common factor to cancel out, you start with 2, right? So for 2, you use divisibility rule. Yeah, 3, right? So you first try 2 didn't work because the denominator is not an even number, right? And then you try 3. What is the divisibility rule for 3? Come on.
you add them up and then they're divisible by 3.
Yeah, so here you should try 3. 2 didn't work, obviously, right? Then you try 3. 4 plus 8 is 12. 1 plus 4 plus 7 is also 12. So meaning that both are multiples of 3, right, everyone? Okay. So you after try 3, you should try 5. After try 5, you try 7. After try 7, you try 11, etc., etc. Okay. You go over the prime numbers, primes. Okay, make sense? Try all the primes. So when you divide by 3, okay, go ahead. What is 48 divided by 3?
And then over 49.
Yeah, it's 16 over 49. And the answer is?
4 over 7.
Right? See, it's much easier. Okay. And you don't actually have this step. You see, this step is pretty weird. Because you had root 3 and root 3 here. When you cancel out, you just get 4 over 7. That is correct. Okay, basically the 2 root 3, the reason why you have 2 root 3s here is that, well, 48 is 16 times 3, and 147 is 49 times 3, right? But root 3s are not root 9s. So I'm not sure why you changed root 3 into root 9s. Okay, 3 is root.
I think I
root,
tried by like the top and bottom by like root 3.
Oh, okay. Have to do that because on top and on bottom, they both have root 3, so you can just cancel out directly. You cancel out everything and get the simplest form. And if at that moment you still have a root on your denominator, that's the time you rationalize the denominator. You don't rationalize the denominator every time. Okay, so here you have 2 same roots, you just cancel out. But the easiest way is always to cancel out terms first. So for H, you didn't do it. I actually show it here. Because 150 and 54, you can just divide it by what? Divided by 6, right? So 150, 54, first of all, they're both even numbers, you divide by 2. And also if you check the digit sum, both are multiples of 3, right? So both are multiples of 2 and 3, you can divide by 6. So if you divide by 6, 150 divided by 6 is 25, 54 divided by 6 is 9, and you get 5 over 3. Okay? Yeah, so that's the only issue I found here. And all the other ones are pretty much the same. And let's look at this. So Justin inventories. Look at the question first. The question is asking us to estimate the value of each radical to 1 decimal place, like root 20, root 76, like all the roots that are like all the roots with radicals that are not perfect squares, right? If they're not perfect squares, without a calculator, you don't know the exact value, but how do you estimate them to say 1 decimal place or 2 decimal places or 3 decimal places and that kind of stuff? Okay, how do we do that? Now, okay, let's first look at Clavon's method, the method your teacher told you to do, right? What Clavon's doing here is that, okay, this is too messy. let's maybe put over here. So let's say we do one of the questions we see here. Let me use my phone to have a look. Let's say we look at the question B, okay? So question B, Clavon is 76. So Clavon's method is that we know that root 76 is between root 64 and the root 81, right? So we first find two nearest perfect squares of the root so that we can have two integers. Okay, this one is 8 and this one is 9. So this means that our root 56 should be between 8 and 9. And that should make sense to everyone, right? It's very simple. If you were asked to estimate any value of a radical, at least you're going to first find out the two nearest perfect squares, one smaller than it, one bigger than it, and then you can find a rough range, okay? So Clavon's method is that you first find the difference between them, 18 minus 64, and that will give you 17. And our current number 76 is 12 from 64, right? So it's sort of like root 76 is somewhat like 12 over 17 away from 64. So we estimate that root 76 is roughly 8 plus 12 over 17. I think that's the method, right? Because in each question, that's what you did. Okay, I literally, it's my first time. It's literally my first time know this kind of method, and that's not correct. Okay, so yeah, so totally interesting. Does this method make sense to you guys? Find the difference between these two numbers and find the difference between the our target number with the smaller number here, and use a fraction to estimate it. But this won't give you the correct answer though. It's not this. For example, here, let me try. Root 76 is 8. Okay, this time actually it gives you correct answer, 8.7. But it doesn't give you the correct answer each time. So for example, let's say, let me try. Okay, like the first one, Clavon, it doesn't give you the correct answer, root 20. So root 20 using our method is 4.4 cycle, right? So that means you're gonna estimate to be 4.4. But the calculator is 4.47, meaning that it should be 4.5 rather than 4.4. Okay, 4.5 is a more accurate estimate. What about, say, let me see the next one. Okay, so question C, yeah, C is actually correct, but sometimes doesn't give you, like D is not. So for D, if you use a calculator, it's actually 2.71 something, but you got 2.6, right? D using a calculator is 2.7, okay? What about E? E is 3.9, so it's actually correct. What about F? The F is also correct. Okay, so sometimes it's correct, sometimes it's not, because it makes a little bit sense, but I don't think it's the best way to do it. Okay, so we're gonna give you a way that always give you the correct answer, and it's also a standard way of, well, other schools. I'm not sure if your teacher gives you why your teacher gives you give you this method. Okay, the other way is pretty simple. So let's say we do root 76 again. We know it's between 8 and 9, right? So between 8 or 8.1 or 8.2 or 8.3 or whatever, then we can try it, right? We can simply just try it. Trying it is the easiest. So root 76. This is method 1, which is not good. Okay, sometimes it provides you with correct estimate, sometimes it doesn't. So for method 2, we're simply just gonna try. So let's say, because 76 is somewhat nearer to 9, right? Closer to 9, but further away from 8. So maybe we start with 8.6. So if we start with 8.6, how do we know if the value is closer to 8.6 or 8.7 or 8.8? Then we just need to square all three numbers, right? Because the square root of 86, it should equal to, well, like 76 should be equal to root 76 squared, right? So if you say you square this, you just need to square all three decimals here and see which one is closer to 76. Okay, you see, it makes perfect sense, right? Because the square root is actually just using a square. So 8.6 squared is 73.96. 8.7 squared is 75.69. And 8.8 squared is 77.44. Then obviously for 76, this one is the closest. So that's why it's 8.7. Okay, so Clovan, does that make sense? Actually, using this method, you can estimate it to be any decimal place you want. Okay, say that you want to estimate to 2 decimal places. You just keep doing this. So for example, 76 is between 75.69 and 77.44, right? It's between them. So that means our answer, if you want to estimate to be 2 decimal places, it must be 8.7 something, right? So we try again. Notice that 76 is closer to 8.7 squared and further away from 8.8 squared, right? So maybe it's around 8.71, 8.72, 8.73, something like that, right? So if we try more, so let's say between these two, we can try 8.71 squared, 8.72 squared, 8.73 squared. Let's first give them a try, see if we can find 2 numbers that contain 76 in it, right? First number gives us 75.8641. The second number gives us 76.0384. So it's good enough. It contains 76 in it, right? So that means 76 must be between them. And that means, well, it's either you can, and which one's closer? This one's closer, right? This is only 0.03 away from 76. So you can estimate to be 8.72. 8.72. So 1 decimal place will be 8.7. 2 decimal places will be 8.72. Okay, Clovan, that makes sense to you? Because this is literally using the definition of perfect squares and, using definition of square roots, right? So this must be correct. It makes mathematical sense. To use fractions, well, it makes a little bit sense, but well, this is better. Okay, and say that you want to do 1 more decimal place. Again, we know that 76 is between these 2 numbers, so it must be between 8.71 and 8.72, right? And again, we see that 76 is closer to 8.72. So it's maybe 8.728, 8.729, 8.727, that kind of thing, right? So it must be 8.72 something, but it's closer to this end. Sorry, so it's like 8.71, maybe 717, maybe it's 718, maybe it's 719, we don't know, but we use a calculator. Okay, so I'm gonna grab a calculator. 8.717 squared, it's 79.8986 and the next one is 76.003524. And that's enough, right? We don't even need a third one. Don't wipe out a third one. So again, 76 is between them. So it must be between these 2 numbers, right? Okay, and which one is the better estimate? This one is 0.003 away from it. This one is 0.014 away from it, right? So the next one, the second one is a better estimate. Okay, so if you're asked to estimate to 3 decimal places, this is the answer. And can keep doing this repetitively, right? It's between them. Again, the next estimate should be like 8.718. Again, it's closer to this end. So maybe 7179, 7178, 7177. Give it a try. Then find the next decimal place. Okay, any questions so far? Doris, Justin? Justin, 你觉得这个方法 make sense 吗？你现在学这里啊？你觉得这个方法 make sense 吗？
能理解。
能理解，就是会用吧，因为这个就是平方嘛，对吧？说白了就是一直试出来哪个对哪个更近，那就是哪个嘛，你能理解吧？所以8.7的平方不到76，8.8的平方呢又超过了76，那你说76的 square root，那肯定在他们俩之间嘛。
是。
对啊，然后这是下一个 decimal。
啊。
那个这个76是不是明显跟75.669更近啊？所以它肯定跟8.7更近嘛，所以就是8.7172。直到你看刚好是从75点多变成了76点多，对吧？那是不是说明你76在它们中间啊？
是。
然后就够了嘛，对不对？要说明就是这两个值，哪个更好呢？你就看哪个值离它更近啊。这76.03是不是离它更近啊？因为跟它只差0.03，是上面这个又差了0.14呢，对不对？所以底下这个数更近嘛，所以说明8.72是个更好的答案。如果是2位小数的话 ，OK。然后如果答案让你3位小数呢，那就是71跟72之间喽，因为71跟72刚好是就完成了从75到76的跨越嘛，对吧？你76在中间嘛，所以说明一定是8.771几，我这里写错了，因为它比72要小嘛 ，OK， 对吧？这一组告诉我们啊，就是说 √76 是不是要小于8.72，要大于8.71啊？明白吧 ？OK。Come on, that makes sense, right? 76 squared, 76 root 这个 ON correct, right? OK, it's between them, 对吧 ，Justin？ 然后呢，8.72是不是离它更近啊？所以下一步我们去算的时候呢，我们就找一个应该是离72更近一点，所以从717啊、718开始算，明白吧？不要从717开始，
但是做出来。
对，就这样一直往下试，不要从711开始试啊，或者712，因为711、712呢。这个数明显离76还远嘛，对不对？底下这个数离76近嘛，所以肯定是靠近8.72的，明白吧 ？Okay, so Clovan, I'm not sure if you understand which numbers to try. Okay, because 76 is closer to this number, right? So meaning that √76 is more situated closer to 8.72. And further away from 8.71, right? So you don't start with 8.711, 712. It takes too long. We know that it's closer to 8.72. So we start with maybe 717, 716, 718, and then you will see, okay? You're gonna find two numbers. You just, you go from 75 point something and then 76 point something. So that means √76 is between them. So again, here it tells us that √76 is less than 8.718 and greater than 8.717. Right? Okay? Because literally those squared are, one is less than that, the other one is greater than that. Just in ba. And which is the answer here? We choose the one closer to 76. This one is closer to 76 compared to the other. That makes sense, right? So this would be the answer if you want to estimate with 3 decimal places. Yeah, just do this repetitively. You can get to any decimal places you want. So in this case, if you try √76 using a calculator, the exact value is 8.71779777887. So you see that? You see, 8.718 is a very accurate estimate. Okay, and again, if you keep doing this, you will always end up with a correct estimate. Okay, any question? Okay, Clovan, does that make sense to you? Yeah, okay. If you understand this, you can, maybe inform your teacher of the method so that he can do better later for other kids, right? And also this can this shows you that you've done extra work outside of class. Maybe it is more impressed and gives you a higher mark. I don't know, okay? But I think you should let your teacher know, and so that he doesn't misguide other students, okay? Yeah, so this is how to estimate the value, and then let's move on to radical equations. So radical basic and multiplication and stuff. If you guys understand, let's talk about radical equations. Come on, I haven't seen your homework for radical equations, so maybe you haven't moved on to there. Okay, so let's just do some examples and see how do we solve radical equations. So radical equations are equations that have a radical sign in it, right? A radical sign in it. So that would be something like a radical sign. Let's say 2x minus 4, 2x minus 3. Let's say equals to x plus 4, something like this. Okay, radical equations, or maybe another square root. Okay, let's say root something equals root something, or maybe the other side doesn't have a root. But anyway, as long as I have a root in it, that's a radical equation. Okay, so to solve radical equations, we're gonna first try to find a way to eliminate the radical sign, right? So any idea? How do we get rid of these radical signs?
You square both sides.
Mm-hmm. Exactly, right? Yeah, because the radicals must be the same. And there we go. It's a linear equation, x equals to 7. Okay, and yeah, does that make sense to everyone? Because when you plug in, you will see, you know, here is 14 minus 3 root 11. Here's root 11. There we go. Okay. For radical equations, once you've got an answer, you must plug in and check. Okay, must check. The reason for this is that sometimes you might have an answer, and when you plug it back in, it gives you a negative answer here. Although in this question we don't see it, but you might have this kind of situation in other questions. So you must check the solution. And also in your school exam, if you didn't check your solution in radical equations, you will lose mark for it, okay? Must check your solution, because sometimes you might have negative values here. Okay, I can give you some more examples and we will see. What about, say that we have still 2x minus 3. What if I'm gonna add a 3 to it, and I'm gonna time it by 4, and then I'm gonna let it equal to 8x plus 15, for example. Maybe plus yeah, plus 15. Anyone, any idea?
I think we need to still square it to get the radical out, or the square root.
Yeah, we still need to square it, but do we square it now?
No, we can first move 3 to the other side and then divide by 4.
Exactly, very nice. Okay, so guys, if you have anything like this, you must, the first step is that you must isolate the radical sign, because to eliminate the radical sign by squaring it, it has to be like in an isolated form. Like this, you square it, this, you square it, you can eliminate both radical signs, right? So if you have any equation has this, this form, if you just square it, you're gonna square both sides, right? If you square it directly, this part, well, it's a term plus another term. Remember, it's a squared plus 2ab plus b squared. It's not gonna give you simply just this being erased. Okay, it will give you, say, 16. So first number squared is 16 times 2x minus 3 and 2ab, right? So 2 times 3 times 4 root 2x minus 3 and then plus 9. You will still have a radical sign. Okay, so make sure you isolate the radical sign first. Okay, so to isolate the does that make sense to everyone? Isolate the radical sign first. Okay, so isolate the radical. So that means, yeah, so Plavon got the correct method. We first move the 3 over there and divide by 4. That means root 2x minus 3 is going to be minus 3. So 8x minus plus 12, right? You first minus 3, and then divided by 4. And here we can actually simplify it. It's 2x plus 3. Okay? And now we can square it. So we square this, and then we square this. Okay, Clement, would you like to continue?
So, 2x minus 3 equals to 4x squared plus 9.
This is just 4x squared plus 9.
Oh,
Remember, a squared plus 2ab plus b squared, right?
and then, so then,
First
12x.
Good. 2ab. Okay, don't ever forget about 2ab, because Clement, okay, again, if it is just a squared plus b squared, then you can actually just square here, right? If you just square here, the first term squared, you don't have a radical sign. Second number squared, you don't have a radical sign. That's it. But the problem is that it's not a squared plus b squared. It's a squared plus 2ab and b squared, right? 2 times the first term times the second term. This part will give you a radical sign, okay? So here plus 9. Good. So what do we have here? We have a quadratic, right? So we combine all the terms. That's 4 squared plus x, and then plus 12 equals 0. Divided by 2, 2x squared plus 5x plus 6 equals 0. Yeah, okay, and then solve by quadratic formula. Okay, so using the quadratic formula, it gives you 2 answers, and plugging them back in to see that if you have negative sign values here. Okay, actually here you don't have a solution, because remember the discriminant, b squared minus 4ac, guys, right? In quadratics, we learned about this. If it is less than 0, you don't have a solution, right? Because this is like the square root of it, right? Okay, so here you actually have 25 minus, well, 48. So it's less than 0. So you don't have a real solution here, okay, for x. And that's because I just come up with random numbers, right? If I use better numbers, I can make it to have 2 solutions. Okay. Does everyone remember this? This comes from the quadratic formula, right? So quadratic formula is 2a, sorry, b negative b squared minus 4ac over 2a, the quadratic formula. And inside our square root, we have b squared minus 4ac, right? So this number, if it is greater than 0, you have two solutions because it's plus and minus. If it equals to 0, then this whole thing is gone. It's 0, right? You only have one solution. And if it is less than 0, you don't have any real solution. Okay, and here is less than 0. So here's no solution. For this question, there's no solution. Okay, that's it. So this is how you solve radical functions algebraically. Basically, you just wanna isolate the radicals and then square both parts, both sides. And yeah, and once you get a solution, always check the solution. Okay, Justin, that makes sense? 明白吧？啊 ，Justin 一定要记住啊，把你的 radical isolate 出来啊，因为不 isolate 的话，你有一堆东西，你一块 square 的话，就还会有 radical，所以一定要把 radical 单独弄出来一边，然后一 square 就没了。 就这样，这个就是 solve radical equations algebraically，就是用代数的方法去 solve。Owen 也明白了 ，Owen， does it make sense? Yeah. Doris, okay. Yeah, we also have graphical method to solve it, but I'll leave it for the next week because to talk about that, we're gonna first talk about the graphs of radical functions. So we're gonna do graphs first, and then we can talk about how to use graphical method to solve for radical equations. Okay. All right, so for homework, Owen, you can practice law of sines, and Clover and Justin just can practice radical equations first, but I believe you have time for both. Okay, you can do both if you have time. Notorious can do both too. I'll send homework later.